Hi, in this video we are going to implement the insert functionality and feature of a binary search tree. So first of all, we would like to make this binary search tree to implement the tree interface, because this is how we tell Java that okay, this binary search tree is a tree basically. And of course we have to make this tree as generic, and of course we have to make this as generic. Okay, so we just have to add the unimplemented methods: traversal, insert, delete, getMax and getMin. Okay, first we are going to store a reference to a root node. Node is going to be the root node. As you may recall, in the theoretical section we have been talking about that basically we can access the root node only whenever we search for a given node, whenever we would like to delete a given node, whenever we would like to find the minimum or the maximum, or we want to traverse the graph in an in-order traversal manner. We have to start at the root node. So we are not able to start at the middle node, for example, or something like this. We are only able to access the root node. Okay, I'm going to have a helper method, basically a public void insert. This method is going to be called from the outside. So I'm going to have data, for example, we would like to insert. First, we have to check whether this root node is equal to null. It means that basically this is the first node we would like to insert into the tree. So I'm just going to instantiate this given new node with the new data. And else we know for certain that we are able to call this insert method recursively with the data, for example. Okay, I would like to rename, for example, this method because there's going to be a method named collision. So that's why in the tree, I'm just going to make this insert node. Not a good method name, but whatsoever. So in the binary search tree, I would like to have this insert node method. Okay, and I'm just going to call this insert node here. So if we know that the root is a null, then of course we have to instantiate it. So it's going to be the first item we would like to insert. And anyways, we have to search for the given place we would like to insert that given node. So that's why we have this insert node. Okay, so first we have to look for the given place we would like to insert. So we have a new data, and maybe I'm going to store a reference to a given node. Okay, so I'm going to have the data and the root node at the beginning. Okay, so we just have to check whether the given value we would like to insert, this given data, is greater or smaller than the given node we are standing on. So if the data is smaller than the node.getData, and it's very important that okay, we would like to use some features like this. So we just want to compare this data we would like to insert with the actual node getData, because we know for certain that if this data is smaller, we have to go to the left. If it's greater, then we have to go to the right. This is what we have been discussing in the theoretical section. If we want to insert 12, it's going to be the root node, so okay, we just have to instantiate it. If we want to insert 4, then we consider the root node. Okay, 4 is greater or smaller than the root node. It is smaller, so we have to go to the left. And because there is no node, that's why we instantiate one and insert it to be the left child of the 12. What if we would like to insert 5? 5 is smaller than the root node, so we go to the left and consider the next node. Okay, 5 is greater than 4, so we have to insert it to be the right child of the 4. Okay, we have been already discussing how to insert and how to construct a binary search tree. So basically this is why we need this comparison. And if we would like to compare generic data, we have to tell Java that this T is going to be a comparable. Okay, what does it mean? Because this T extends the comparable and this data is a comparable, it means that we are able to call the compareTo method. So we just have to use the data. Sorry, maybe I'm going to rename it to new data. So this is the new data we would like to insert. And if we come to the conclusion that this new data that compared to node.getData is smaller than 0, okay, what does it mean? It means that this new data is smaller. If you hover your mouse this compare to method, it's going to tell us, it's going to return -1 if this is smaller than this. It's going to return exactly 0 if this is equal to this. And it's going to return +1 if this is greater than the node.getData. So now we know for certain that the new data is smaller, so we have to consider the left subtree. So if the node.getLeftChild is not equal to null, it means that we are able to consider that subtree. So we just have to call this insert node method recursively with the new data and the node.getLeftChild. What does it mean? Okay, maybe I'm going to write the else. Okay, what does it mean that else? We know that the left child is a null, so we just have to instantiate a node and we just have to insert it there. So it's going to be the new node. I'm just going to insert it, this new data in the constructor, and we just have to set the left child to be equal to this new node. Okay, so what does it mean? We come to the conclusion that the new data we would like to insert is smaller than the given node's data. And we come to the conclusion that we have to consider the left subtree. But there are two cases. The first is that the left child is not a null. If it's not a null, then we just have to call this method recursively on the left subtree. So we just have to go to the left. This is what we have been discussing. Else we know for certain that the left child is a 0 and the given data is smaller than the node's get data. So we just have to instantiate a new node with the new data and set the left child accordingly. Okay, else we know for certain that this new data compared to node get data is going to be greater than 0, which means that we have to consider the right subtree. And of course, again, we have to check whether the right child is not equal to null. It means that if it's not equal to null, then we are able to call this method recursively with the new data and get right child. Else, what does it mean? That a right child is equal to 0, but we have to insert the node there, so we just have to instantiate a node with a new node. I'm just going to instantiate the node like this with the new data, and we just have to insert it to be the right child, so set right child to be the new node. Okay, and what's the problem? I think that we have to add the unimplemented methods, okay, such as the delete, getMax, getMin, and insert node. Okay, sorry for that, we have to modify it. Okay, that's the problem. I'm just going to get rid of this, and in the tree interface we have to modify that the insert node is going to get a data and it's going to get a node T, for example, with the name node. If I save it, the error should go. Okay, the error gone away. And basically this is how we insert a new node into a binary search tree. We just have a data, we just have a node, and we just have to consider whether to go to the left or the right. And on every iteration we have to check that, okay, we have to go to the left because the new data is smaller than the node get data. So we have to consider that, okay, are we able to go there? So if the left child is not a null, it means that we are able to go there in a recursive manner. Otherwise, we just have to insert the node there. Else, it means that the new data is greater, so we have to consider the right subtree. If the getRightChild is not equal to null, we are able to call it recursively. And we hop to the next node. Okay, it's very important that we are able to go to the left in the right subtree after making this step. But on every iteration we have to call this method recursively. And if we come to the conclusion that the given child is a null, we just have to instantiate a new node and set the right child accordingly. So we have to visit the left subtree in a recursive manner and the right subtree in a recursive manner. Okay, so that's all about the insert method. Thanks for watching.